19.3 Gravitational Fields. In this lesson, you will learn how to calculate the gravitational field strength for any planet from any distance above the surface of the planet. Using Newton's law of universal gravitation, we can calculate the gravitational force between any two objects. For objects on the surface of the Earth, we need to consider the mass of the Earth. We'll use capital M for this. The mass of the object on the surface, we'll use small m. And the radius of the Earth, the distance from the surface to the center. The formula is Fg equals g, big M, little m, divided by radius squared. But for the surface of the Earth, capital G, the mass of the Earth, and the radius of the Earth are always the same. Doesn't matter where you are on Earth, the mass of the Earth is always the same mass. For this reason, we can replace these three values in the formula with a constant. This constant may look familiar to you. We use the letter G in lowercase. So G uppercase, big M over R squared, is replaced with little g, which gives us Fg equals g times m, which might look familiar. Fg equals mg. We can use this to calculate the value of little g for the surface of the Earth. Little g equals gm over radius of the Earth squared, which is 6.67 times 10 to the negative 11, times the mass of the Earth, which is 5.95 times 10 to the 24, divided by the radius of the Earth squared, which is 6.37 times 10 to the 6, squared. This gives us a very familiar value. G equals 9.81 meters per second squared. And that's where that value comes from. The constant g is the same everywhere on the surface of the Earth. It's even the same near the surface of the Earth because a small distance is pretty tiny in comparison to the radius of the Earth. G is called the gravitational field strength of the Earth. You can calculate the gravitational field strength for any planet using the formula little g equals universal gravitation constant times the mass of the planet divided by its radius squared. For example, the mass of Neptune is 1.03 times 10 to the 25 kilograms, and its radius is 2.46 times 10 to the 7 meters. What is the gravitational field strength on the surface of Neptune? The formula is gravitational field strength equals gm over r squared, which is 6.67 times 10 to the minus 11 times the mass of Neptune, which is 1.03 times 10 to the 25, divided by the radius, which is 2.48 times 10 to the 7 squared. This gives us a gravitational field strength on the surface of Neptune to be 11.1 meters per second squared. The value of the gravitational field strength, small g, decreases the further away you get from the surface of the planet. For example, what is the gravitational field strength? 1.914 times 10 to the 7 meters above the surface of the Earth. So we have the Earth, which is a mass of the Earth. And the Earth has a radius. We're going to call it RE. And we're looking for the value of g, 1.914 times 10 to the 7 meters away from the surface. Now, the radius in the gravity formulas always relates to the center. So the total radius is the radius of the Earth plus the 1.914 times 10 to the 7 meters, which is 6.37 times 10 to the 6, the radius of the Earth, plus 1.914 times 10 to the 7, which is the distance from the surface. The total radius is then 2.551 times 10 to the 7 meters. The gravitational field strength at this distance is gm divided by the distance squared, which is 6.67 times 10 to the negative 11 times the mass of the Earth, which is 5.95 times 10 to the 24 kilograms, divided by the radius, which is 2.551 times 10 to the 7 squared, which gives us a gravitational field strength at this distance of 0.61 meters per second squared.